Hello everybody, good morning. I'm sorry it's so hot in here. Here's my talk. I'm going to talk about cloning Netflix. And as a kind of if you read one of the early abstracts, there was going to be all about how you build a video-based app. Turns out in iOS that's not that hard. So instead I'm going to talk about a little bit about how I went and put together an app. So this is an app, so you may be aware, RWDevCon makes a lot of videos. A lot of people complain about the fact that we don't have an app for those videos. You have to go and watch it on the web like some kind of heathen out of, like, I don't know, the olden days. So it would be really nice if we had an iOS app. So we've been working on that. So this is a little video of the app that I'll leave running in the background. You can kind of log in. It then gives you a big old list of all of our video courses that you've got. You can navigate through them. You can click into them. You can see all the videos. It recognizes how many things you've watched, how many things you haven't watched, tells you where you want to start watching, allows you to watch them, allows you to drop them down into, what do you call it, over-the-top type thing. There's a good word for that I can't remember. It allows you to kind of do all of the stuff that you would expect from a video app, like Netflix, and hence if you write Netflix in the title, more people might come because it sounds exciting type aspect of it. So this is the app that I've been working on kind of in the background, kind of towards this talk, with the idea that eventually we'll be able to release something like this. But so what we're going to do today is look at some interesting aspects of this that I thought might be of interest to you. Now, the first thing to mention before we get into any of this is that I've used quite a lot of third-party frameworks in this. If you are a person who hates third-party frameworks, you feel free to leave, or you can sit there and seethe silently throughout it. I don't apologize for it. I started this with the idea that everybody says don't use third-party frameworks, so I won't. And then I got so sick to death of not being able to achieve anything that I decided I'm going to use something that somebody else has written who's far cleverer than I am. So that's where we got to. So what we're going to do as part of this, we're going to put it in 3 sections like all of the other talks. The first part is going to be modeling the API. So we have an API that is the backbone of all of our video store. We call it Betamax. We're going to look at how can we model that, and we're going to use a third-party framework called Moya for that. And I'm not necessarily saying you should go and use Moya, but I'm showing you a way that you can model APIs that works really nicely in Swift. So that's our first thing we're going to do. The second part is going to look at local caching. Right? If I have this API, I want to be able to have a local cache of that so that every time you navigate through the app, I don't have to make a web request and then come back. How can we build a local cache? We're going to do that using Realm, and we'll look at that later on. And then the final part is one of the easiest things you can possibly do in computer science, and that's how do you automatically sync a cache. So we're going to have a cache locally on the device, and we want to push that up to the remote API, and vice versa. So how can we look at that? So to start out with, I'm going to talk a little bit about the API that we're going to model. This is a tool called Pour. If you've not used Pour and you're doing APIs, you really should take a look at it. It's really nice. This and Charles go together really nicely together. So over on the left-hand side here, we've got a set of the different API endpoints that we're talking about. Now, RWDevCon has all kinds of videos. We have them collected into a course. And right up at the top there, there's this thing called All Collections. And that API endpoint will give you a list of all of those, all of the collections, all the courses that are available. Within there, you can grab information about a specific course. A bit further down, we can grab loads of information about a single video. There's this thing called Viewings, which is about which particular videos and the progress through particular videos that a user has watched. They're called viewings because otherwise you end up with like the term progressors, and progressors isn't really a very nice word. In fact, probably not even a word. Then we're going to look at some screencasts and various other bits and pieces. So in Pour, that all appears on the left-hand side, and we might look at what responses we get from the API in Pour as we go through. One of the important things about this is in the middle pane of this, the laser doesn't really work here, the middle pane, which is about here, that there sets up the request. And one of the things that we need to set up with our requests is authentication. Authentication on our Betamax API just uses bearer authentication, fairly standard way of doing authentication. We'll look at that in more detail. Here, then all you're doing is passing an HTTP header called authorization with a particular token in it. And over on the right-hand side, we get all of the different results back from that API. So this here is showing collections. It's got a root node of an array of collections. This is all JSON, by the way, but this is formatted nicely. And then you get a list of the different collections within there. Moya then. So Moya, as I mentioned, is a third-party framework, and it abstracts the idea of building an API away from all of the networky stuff. You don't have to worry about the network layer. You just build this nice abstraction of what an API should look like. And as I said, Moya is a way of doing it. I recommend if you don't like third-party stuff, that at least you consider maybe this is a nice way to model your RESTful APIs. So how do we do that in Moya? Well, first thing, we create an enum that represents all of the different endpoints that we want to be able to talk to. And then within that enum, we tell Moya how to construct the request to each of those endpoints. Then we make a request, and then we map the response, the JSON response, to our local data modeling objects. So, demo 1. What are we going to do in demo 1? We're first of all going to model the get screencasts API in Moya. So I mentioned that we've got all these Betamax API endpoints. The first one is, how do we get the screencasts? A big list of screencasts. We're going to integrate authentication using a Moya plugin. We'll see how easy it is to authenticate. And then finally, we're going to do something, rather than just a get request, we're going to do something where we go back and push user progress back up to the API. So with that, right, if you open up the cloning Netflix folder in the big old thing that you downloaded. Then you want in demo 1, there's a starter project. Inside Betamax API, there's an XC workspace. Now, all of this stuff, does everybody have Xcode 9.2? Oh, you beautiful people, thank you. This uses precompiled binaries, which means that it doesn't work with Xcode 9.2 and 9.3. If you want to use Xcode 9.3, then there's instructions in there, but I'm not going to go into that. So open this up using Xcode 9.2, or fetching. Come here. Don't. There we go. Xcode 9.2. I'm going to say yes. And then the first thing you've got to do is, so basically this is just a playground, but it's presented as a workspace, because I want to use a framework within there. So it's all a bit of a faff, just so that we can use a nice playground. So if you, what you need to do first is, let's do a clean. So if you go to product and hold down Option and do clean build folder, so that's Option Shift Command K, just to clean the build folder, clean it all. You shouldn't actually do anything, but you might need to check that. And then finally, just you need to build it. There's this Carthage dependencies thing that should copy it in to allow you to use a framework within a playground. And let's get all that crap out of the way. And then you can see that all we've got so far inside this playground is import Moya, which, if it's still got a red underline in it, just repeat that clean and build a couple of times, disappear out of the playground, come back into it. It will eventually work, I promise you. Oh, in fact, there it is. No such module Moya. Brilliant. Eventually, this will be happy that it does exist. So if I jump back into there, back into the playground, it will. I'm willing it to work. Let's just try another build. Oh, maybe you need to change this to the correct an iOS target. Let's leave it for now because I think it'll. Let's start working and see if it decides it's going to be happier. Okay, so what we need to do first, as I mentioned, is we need an enum to represent this endpoint. Now, the two endpoints that we're going to do, if I take a look inside, what's this called? Inside POR, I've got all screencasts. That's the thing that I want to model. So this thing here says /API/v1/videos. When you execute that, then it will return a list of all of the screencasts. So if I zoom that out, jump back over here, then I need to make, as I mentioned, an enum, and we'll call it Betamax API. And this is going to, let's put that up there. This is going to be the, this models the two endpoints that we're going to model first. So the first one is going to be called case show screencast. And the second one, case show video. And then we need to specify a particular ID for that video. So I'm going to stick a, not an IPC voucher attribute manage, thank you, an int in there. Go away. Perfect. So that's all we've done. That's kind of the thing that tells it these are the endpoints on the API that we want to care about. Now we need to start adding some compliance, not the word, to the correct Moya thing. So I'm going to set an extension on that API that's going to adopt the target type, which is a protocol. And then if we give that a second, there we go. You should get something saying it does not conform to protocol target type. Target type is part of Moya, and it's the thing that tells it this is going to represent an API. And so something that's fairly new in Xcode is I can say fix, and it will give me protocol stubs for all of the, in this case, properties that are part of that protocol that I need to adopt. And this is what I quite like Moya, or this approach of doing APIs, is that this splits this up into things that make sense to go together. So the base URL for our Betamax API is, we're going to return a URL, and we're going to make it from a string. Here's a string. And that string will be https videos.ray-wenderlich, which I can't type, .com. I can't type that either. /API /v1. Ignore that dot. Let's get rid of that full stop. And then we need to put an exclamation mark on the end so that it doesn't shout at us. Okay, so this is the URL that all of our other endpoints will use to form their particular paths. And in most APIs, you would have a base URL, and then you would add separate paths on the end. So that's the thing that goes at the beginning of all of our requests. Next up then is the path. Now this is what do I put on the end of that base URL to form each of these requests. And in this case, it actually differs dependent on our on the endpoint that we're calling. So the first one, we're going to switch on self because of that. We need two cases. We need a case called show screencasts. And for show screencasts, we just return /videos. And we're not going to do default. We'll do show video. And we do need the ID, so let's pull that out. And then here, we're going to do return /videos. And then with a bit of string interpolation, just inject the ID. Does that kind of make sense? So if I show you, everybody got that? I'm just going to show you that in POR. So we've got this all screencasts, which pulls down this /API /v1/videos. And then if I want a single screencast, then it's got this endpoint here that's /API /v1/videos and then the ID. So all we've done there is model exactly that with those two different paths. Very simple. Okay, method. This talks about the HTTP method that is required to request this particular endpoint. In both cases here, we want they're going to be get. They're both get methods. We'll come back later on and add other methods as well, but for now they're just get. Now this sample data thing, sorry, I'll leave that on there so you can get it. This sample data, now this is a nice feature of Moya, but it's not a nice feature of Moya when you're writing tutorial type presentation-y things. This kind of integrates the ability to provide unit testing sample data. So you would fill in here, and then you would be able to provide different responses, different modeled responses for the different endpoints. But that's not very helpful when we're doing a tutorial because we haven't got all day. So instead here, I'm going to completely ignore this and just return an empty data object. Next up then is task. And task, you can think of this like thinking of URL session task. It's now that I've worked out what address I'm calling, what HTTP method I'm using to call that endpoint, then what am I actually going to send with it? And that's what the task is. And once again, I need to switch. I'm going to switch on self. And we need to do a couple of different things. So we'll once again do show screencasts first. And for show screencasts, then if I quickly jump back to POR and see we've got all screencasts, and I look in URL params, then you can see that I have to pass a URL parameter called format with a value of screencast. And what that actually looks like down here is you end up with this thing that says, you see that? This is just standard URL parameterization on the end of it. So you can do that inside Moya with, I've got show screencasts. I want to return in here something called request params. Oh, God, which one is it? I can't even tell how many letters I've typed. I think, have I got an S next? Parameters. There, that looks about right. And you pass in parameters. And in here, this just takes an array of string to string. It's not an array, it's a dictionary, isn't it? Format. And it goes to screencast. So what that is doing is saying, when you're going to make a request to the show screencasts endpoint, then I want you to pass in, oh, I've not quite finished it. I need you to send the parameters, or the parameter format with the value of screencast, and the way that I want you to send that, and we have to add this encoding option, coding, and here we're going to use URL encoding, bloody hell, URL encoding, and we do that with query string encoding. That means it'll add it to the end of the URL. And instead of default, let's replace that with show video. Case.show video. If you do this, now we don't actually care about the ID here, so I can just delete that part of don't need it. So case show video. And then in here, this is just going to be a plain old request. So I can do a return.request plain, which is that one there. That means it doesn't add anything to it. It just sends a request. It's a get request to a particular path with a particular URL. And the final required section is this headers section. And headers, just HTTP headers, you can put whatever headers you want in there. In this case, I'm going to show you a demonstration of that by putting the content type in. So I'm going to put a content type header in. And that content type is application/JSON. You might not need that. And in fact, with our API, we probably don't. I just want to demonstrate that that's what you can use that headers for. So with that, if everybody's got that? With that, what we've got, right at the top, we put the base URL in. We then tell it, for each of the endpoints we're modeling, what should we add on to that base URL? Then, how do I need to communicate with that base URL? What HTTP method do I use? And then the task is, what other information do I need to provide? And we'll see later on other ways of doing it. Here we've just added URL params on the end. So now we've done that, how do we actually query it? How do we make a request to this? First of all, I need to create a provider. So I'm going to make a provider, which is going to be a Moya provider. It is generic on the API that I've created, so Betamax API. I'm just going to instantiate one of those. And once I've got that, then I can make the request. And in actual fact, this is quite easy now. So I'm going to do provider, request. And then I put in which endpoint do I want to make a request on. So I'm going to put in show screencasts. And then I provide a closure that handles the result. So we get result in. Now result is it's an enum in its own right that has success or failure as its two options. So I'm going to switch on it because we love switching. We'll stick a result in. And the first case will handle success, because that's what we'll get, obviously. Let response. So a success, when you get success, you'll be provided with a response object that we can then do stuff with. This is the response from it. So with that success, I'm just going to print a couple of things out here. I'm going to print out the response, and it's called status code. So this is the HTTP status code from the request. And I'll also print out what is the actual response. Sorry you can't see the line that I've just typed. Let me finish this and then you'll be able to see it. The response itself it will be, I can get the response body, which would just be a data object. So I'm going to map that to a string with using string bytes. And then you put in response.data. And then we need to stick the encoding in, which will be UTF-8. And we probably need to put an exclamation mark in. Okay, so all we're doing there is just printing out the status code, which would be like 200, 400, 500. And then we need to handle the failure case. And because this is a demo, what do we do with the failure? Well, to be honest, this is what I do in production, so it doesn't really count. Let's just print it out. Nobody cares. And that should tell me it's exhaustive. There we go. So that there represents everything that you need to do for a request. And in a moment, we'll see how easy it is to change that. But let's run that. So to that, you need to hit the little play button down in the corner, which you probably can't see. There it is. Now I can't move. There we go. So hit that, because I don't have the playground running automatically. And you should hopefully get a response. So you have to be on the network for this, obviously. I probably should have mentioned that at the top. You get a response. And the response is 401. 401 is access denied, or well, it says access denied. And then the response that we actually send back from our web service says that the HTTP token access denied. And that's because we haven't done any authentication. Has everybody got there? Everybody that wants to get there has got that? Yay. Magic. So how can we authenticate against this? Now, if you remember back to POR, I showed you, here we go. Inside the headers, we have this authorization header, and you pass in the token. That's a standard way of doing bearer authentication over HTTP. So how do we do that in Moya? And where the hell does this token come from? Let's get our token first. And to do this, you need to open a browser. Whichever is your browser of choice should work. And if you visit, let's zoom in a bit. No, not that. You want to visit accounts.raywendelick.com/debug. And if you go there, then if you've already logged in, then you're done. If you're not, then you'll need to log in. If you don't have an account with us, then you can just leave, because, I mean, why are you here? If you don't have an account, you can sign up for an account. Very simple, and hopefully this will all work. I mean, the internet is working, touch wood. So I'm just going to sign in with an account I made for this. There we go. I'm going to blame that on somebody else who's not in this room. It's my fault, though. So has everybody got a page that looks roughly like this? Magic. Wicked. Right, so on here you've got the user ID. We need the user ID and we need the auth token. So if you grab the user ID, copy it out of there, back into the playground, just before you specified the provider, then I want you to put let your user ID equal, and paste that in as a string. Don't copy mine out. And then do the same for this one here. So the auth token is a big old JWT auth token, and paste that in there as well. So this, in the app itself, this all happens in the background. But we're doing it explicitly here so that we can see it working. So now that we've got that, how do we actually go ahead and use it? Well, Moya does this quite nicely. And the way that we do it is by telling it, it has this concept of plugins. And one of the plugins is an authentication or authorization plugin, one or the other. And so what we can do is declare conformance to that. So down here, I'm going to add another extension onto the Betamax API. That's that enum we started with. And it's going to add conformance to access token authorizable. Access token authorizable. And if you leave it a second, it'll tell you that it needs something for you from that. I'm going to add the protocol stub, and this just has authorization type. In here, I'm going to return, and you can choose. It implements 2 different authorization types, or 3 if you count none. But why you would do that, I don't know. Basic authorization is kind of username, password. We're using bearer authentication. These are just standard HTTP authorization techniques. The bearer one is the one that adds the authorization header with the bearer or token contents. So once you've done that, then now Moya knows that whenever it makes a request, it needs to use the right kind of authentication method to be able to, and it will add the header appropriately. I now need to tell it, well, where should it get that value? And to do that, we do that when we instantiate the provider. So add a couple of lines in here, and rather than using the empty initializer, I'm going to add one that uses this method. Takes this parameter called plugins, which is an array, and inside that array, I'm going to add access token plugin, which should take a token closure, and in there I'm going to put the string. So it says token closure. It's actually an auto closure, so I can just pass it a string, and then it'll turn that into a closure for us. The reason it's the reason that if you wanted to, you could use a closure. We don't need to go into that, but if you wanted something that was dynamic, you could use a closure there. But because it's an auto closure, I can just stick that string in. That auth token string is this big thing that you pasted out here. Does that make sense? Wicked. And now if I run the playground again, so if I hit stop and hit play, scroll this up a bit. And here we go. So we should now have a big boatload of JSON guff arriving in there. This is a list of all of the screencasts that are on Betamax on our videos side. And you see right at the top, you've got this is a video. Oh, get out of the way. It's 200, so it means it was successful. You should have a key right at the top called videos, and then within there, there's an array, and each one has a load of information about each of those screencasts. Okay. So that's quite, we had to do quite a lot of work for that, and you might not really see the advantage of building up an API like this. But I think the next little bit will hopefully give you some kind of reasoning why this is quite a nice way of doing it. So we're going to do that by saying, well, I want to request information about a specific video. Remember back in Pour, then we had the give me all the screencasts, and then there was also an endpoint that said, give me lots more information about this specific video. So how would we go about doing that? Well, if you take this provider request show screencasts and replace show screencasts with, what was it called? Show video. And that takes an ID, which hopefully autocomplete doesn't work, and put in 1419. I don't know what it is. I know that that exists. And then stop and run it again. Then we should see, yes, there we go. We now have a top-level key called video instead of videos, and within there, there is a whole load of information about that specific video, including things like the where you like the zip files and all of the artwork and that kind of stuff. That's what we get with that specific video endpoint. So that there, to me, is one of the reasons that I really like this, is that I model the API, I change one tiny little bit about my actual call point, and then everything changes. It really is quite easy. I've abstracted all of the API stuff, all of the network stuff is miles away from where I'm actually using it. Okay. I'm aware that sorry, I should have said at the beginning, this demo goes on for longer than it should do. I apologize for that. I just love the sound of my own voice. We're going to carry on with this for about another 5-10 minutes or so, and then we'll move on to the next demo. But I think this is it's quite interesting. So I'm going to carry on. Now, one of the key things about Netflix is that it knows exactly what you've watched. It knows how much of different episodes of things you've watched, knows how much binge-watching of Friends you've done or whatever else it is. And one of the great things about that is you go back to the app and it will carry on from where you left off. One of the less good things is it then suggests all kinds of random crap that other people have watched that it might think you like. So if you watch one terrible thing, you end up with recommendations of that awful thing continuously. Now, we don't do that yet. Because we don't have any terrible things, obviously. But we do want to be able to register what people have watched so that we can then help them pick back up where they left off. So we do that again with some endpoints, and that's that viewings endpoint that I spoke about before. So we're going to model 2 extra endpoints. One is give me all the viewings, give me all the progress data for this user. And the other one will be I want to update this user's progress for this particular video. So how do we add extra endpoints to Moya? Well, we scroll right up to the top where we first created our Betamax API enum. And in here, I'm going to add 2 extra cases. The first one is going to be get progress. And for this, I need to pass in a user ID, which will be a string, so that I'm requesting the progress for a particular user. And then I need another case called update progress. And this, once again, we're going to do it for a particular user. So that's a user ID, which is a string. And I also need to pass in the progress. And here I'm passing in a type called progress params. And if I'll just show you what that is. There's nothing clever about it. It's inside sources, inside the playground. There's a progress params struct. The only important thing about it is that it adopts the decodable protocol. And we'll use that later on. But all it is just a really simple struct that contains the different properties that we get from the API. So if I go back to the playground and get rid of that. Now, because we've used switch all over the place, we now end up with a load of places where we are no longer exhaustive, so we need to cheer it up. So the first one is the path property. So we've got two new cases, but we need to add them in. And actually, they both take the same path. So I want to do get progress. And I do need the user ID for this, so I'm going to stick user ID in. Then I can stick a comma and do update progress, because they're both going to use the same path. But however, for update progress, I don't care about the progress for this, so I'm just going to stick an underscore in there. And the result for this should be return, need a new page. Come on, there we go. Return /users/ bit of string interpolation, user ID, /viewings. A fairly standard RESTful kind of API. Okay, everybody got that? Magic. The method, so it's not complaining about the method because we don't have a switch in there, but actually we do now need one because update progress is a post HTTP method, get progress is a get method. So for this, I'm going to switch on self. Switch on self. The case for update progress, and here I couldn't care less about any of the parameters that go with it, so I'm just going to put update progress. I'm going to return post. And the default one, I'm going to return get. Okay? I'm just going to cough. Excuse me, thank you. And then it's complaining about the task, once again, because I haven't got an exhaustive switch statement. So in here, show video and and get progress are actually the same. So I can stick get progress in there as well. Don't need the user ID. They're both plain requests. And then the final one is update progress. And in this case, I don't care about the user ID, but I do care about the progress. And here, this is something that's quite cool. Remember that progress params was codable, which means that I can turn it into JSON without doing anything. Well, here, I can tell it that when you get one of these, I want to return, not retrun, return, a .request JSON, I think it's that one, with encodable type. Yes, request JSON encodable, and put progress in there. How many letters have I typed? Progress. There we go, progress. So what that's going to do is when you pass it a progress params to the update progress method, it's going to turn it into JSON and send it as the body of that post request. Really quite nice and simple. And if we run, do we want to run that now? I guess we probably do. So if I go back down to my request, where we've got this provider request, instead of show video, let's do get progress. Hello? Can I type? Thank you. Get progress. And you remember you have to pass in the user ID, and I think I called it user ID. Did I? Yes. And then I run that. Then you will see, if you've ever watched any videos on the site, then you will get a list of things like this. If you haven't, you should end up with an empty array under the viewings key path right at the top there. And this contains things like the user ID. It contains things like the duration of the video you've watched, how far through the video you've watched, and various other bits and pieces. They're not very helpful as JSON, but what we can do is decode that. Because our progress params is codable. We've used the encoding side of it. Now we can use the decoding side of it. So here, instead of printing out the string, so this is inside the success case, Let's comment that out. And in its case, we're going to try and decode it. So we can do progress equals try with an exclamation mark, because it's always going to work. We don't need to worry about it. Response, and then it has a map method on it. So this is the Moya response. It has a map method on it. You pass in the type, which is going to be an array of progress params dot self. So you should recognize this as anything that you're doing with encodable, decodable. It's exactly the same kind of thing, because all it does is defer to it. But the one thing we do need to do is add this this argument called @keyPath, which I think I've typed there. Yeah. And that's because if you look down here, I've got the top level of it is not an array. The top level is called viewings. So it adds this @keyPath thing, which will extract it out of there. My top level key path, therefore, will be viewings, like that. And then rather than having a look at a massive load of those, let's just print out one of them. So we'll do print progress. Oh, can't type. Progress.filter. And we'll just find the one for a particular video. Hello, video ID equals, we'll do 471. It's a particular favourite of mine. What's wrong with you? Why are you not? Is that right? I think so. No, what's wrong? Progress. Oh, because I missed out an R here. Progress. Happy with that? Yes. So if I now run that again, we should see that it has managed to decode that. Now, if you've never watched whatever video 471 is, you should end up with an empty array there. If you have watched it, then you will get something that tells you how far through the video you got, whether or not you finished it, and its total duration, which should be 447. Okay. So one final thing that we need to do for this first demo. All we've done so far is GET requests. We've just pulled stuff down from the API, but we created the update progress endpoint. We want to be able to use that. So how would we go about that? And we're going to do this by putting in a progress for this video 471. So what we're going to do is before this GET progress request, which we'll leave in, so stick some lines in. We're going to do it here. So just before that one, I'm going to create an updated progress object, updated progress, which is going to be a progress params, and that takes a video ID, which will be 471. It takes a time, which we're going to put in 440. The duration is 447, and we'll say that we have finished it. So the point is that that's all different to the stuff that I've written in here. The stuff that I've pulled out from the API. And then we need to make the request. Now, we could type it out again, but I'm a bit lazy, so I'm just going to copy this request here, which is easier said than done. So I'm just going to copy that and paste it in above. Now, out of here, I want to delete, inside the success one, delete the print and the progress and all that stuff. All we want left in there is the status code, the response status code. And then the request, we change that from get progress to update. Hello. Change that to update progress. Pass in the user ID. And we also need to pass in progress, which will be the updated progress thing that we just built. All right? So now what we've got at the bottom of here is we've created an updated progress object, struct, thing, value. We're then going to send that to the API using update progress. And then we're also down here, we get progress for that same thing again, and we filter to find it. And hopefully we'll see that instead of, if yours is empty, then it will have a value. And if it had one example, if it had a value already, the time should change and the finished should change. So let's run that again. We get two 200s, and then down, so that's the update request, that's the response for the get request. The time is updated to 440, and finished has changed to true. So we've managed to update that progress by creating a progress object and then just pushing it to the API through Moya. And with that, we're done with the first demo, which has taken longer than probably wanted, but I think we've done quite a lot there. We've actually modeled a complete API in like 100 lines of code, and that I think is pretty good. And we didn't have to do any fighting with network stuff. This is all built on top of Alamofire, but there's nothing to say that you couldn't use a similar kind of model with your own apps that doesn't use a third-party framework. I'm just lazy. So let's go back to some slides and see what's coming up next. Okay. So we've started out, we've now got Moya in there. I've mentioned that we wanted to do some caching, and we're going to use Realm for a local cache, and we're going to use Codable, because we've started using Codable, but we'll do it a little bit more. So first thing, let's look at a tiny bit of stuff about Codable. Excuse me. This example here is talking about JSON decoder. So this is just the JSON decoder API, and you've probably used JSON decoder. If you've done any stuff with Codable, you've probably seen JSON decoder. The important stuff on here, there's a couple of things. First of all is this allows you to specify the way in which it should decode dates, the way it should decode data. And down at the bottom there, there's key decoding strategy. And that is the way that it handles what the keys look like in the JSON and what they should turn into on your local data objects, whether they be structs or classes or whatever they are. Now, the annoying thing is, when I first wrote this talk, I did it with Swift 4.1 all the way through, but then Apple took far too long to actually release Xcode. So key decoding strategy only exists in Swift 4.1, which is thoroughly frustrating as I fixed it last week, because that was going to be a nice little thing to talk about in this section. So instead I'll talk about how I can't talk about it. The next thing I want to talk about is how does decodable actually work? What happens? The decodable, the codable protocol is a combination of the encodable protocol and the decodable protocol. This is all the decodable protocol is. It adds an initializer from decoder and it gives you a decoder. That's all it does, is it provides this extra initializer. That's all it does. Why am I telling you that? Because most of the time you do not care about this, because one of the things that's nice about decodable is that the Swift compiler can infer or write your implementation of this for you at compile time. There's nothing clever going on at runtime here. This is all done at compile time. The reason I'm telling you is because one of the things that I want to do is decode these into Realm objects. And once you do that, the Swift compiler can no longer help you. You have to do it yourself. So we're going to look at how do I implement decodable in my own subclasses where Swift can't do it for you. That's one of the things we're going to look at. And the thing to remember is it's just this one method. Realm. Has everybody heard of Realm? Cool. Who uses Realm? Okay, a few people. Good. So Realm it's a lot of things, but I'm just using it as a local data store. It's quite a nice little database. It's quite easy to use. It has some nice features of it that we're going to look into in a moment, but it's just a local data store. You could equally use SQLite. You could use anything that you wanted to, but I'm interested in using Realm. So once again, we're talking about some techniques that are specific to Realm here, but they very much could generalize into your own apps, into whatever data store you want to use, Core Data, SQLite, a piece of paper and a printer, whatever you want to do. One of the things that I really like about Realm is that it implements the observer pattern. So I'm going to talk you very briefly through the observer pattern in case you don't know what it is. Effectively, I have an object. It is a red object. Over there, look, it's red. And what I want to know is, tell me when that object changes color. So the way that I can do that is I have a green object that wants to know if the red object changes color. So it tells the red object, can you tell me if something happens? And in fact, you can have a whole load of those, a load of these different observers that all observe this object. And then when the object changes color, then it sends out a message to the things that have registered as observers. Sends out the delta, so in this case it's telling it that it went from red to purple. And then that gets delivered to each of those things that have registered as observers. Which is that's not a particularly complicated thing, but when you see that in the way that we're going to use it in Realm, it's really quite nice because we can get rid of some of the asynchronous mess that you get with network stuff. So we're on to demo 2. What we're going to do in demo 2, first of all, we're going to customize Moya's JSON decoder. So one of the things that happens with the API that comes in is that the date formatting does not match what JSON decoder expects for the date formatting. So we're going to customize that date formatting. The next thing we're going to do is see how to implement decodable on a Realm object. So Realm objects are basically the things that Realm can store inside its database. and I want to make that so that it's decodable, so that I can pull in something from a JSON API and automatically turn it into a realm object. That's where the custom version of decodable comes in. And then finally, we're going to look at realms reactivity to deliver asynchronous results from the network. So we'll see how all of that kind of fits together. If I mince back over here briefly. I went for a run yesterday, and that means I can't walk. I'm not very good at running. Or it seems walking. Right. So in here, we need to go back into demo 2. We need to go into the starter project. And, oh, no, I needed to show you something else first. I ballsed this up. Can you visit this, please, and download the zip file that comes there? The reason for this is that I don't know, presumably it was my fault. It probably was. The app that you've got doesn't, there's something missing from the image assets library, which means that it won't compile. And the annoying thing is it's completely orthogonal to what we're trying to do. So it's deeply frustrating. So you just need to download that. That should be a zip file called icons.zip. It's like 60K or something. Once you've grabbed that, then I'll show you what we need to do with it. I apologize for this because it's not very helpful. Has everybody got it? Everybody got that Earl magic? Okay. So what I want you to do is go into demo 2, into the starter project, and open Emetron. Emetron is the name of this, by the way. So we're now looking at the video playback thing that you saw a video of right at the beginning. This is the project, and if you go into assets.xc assets, you'll see that we've got colors and placeholders. We're missing the thing called icons. And if you find that icons directory, which I've got here, so this is the thing. This is what it looks like when it's been unzipped. It should have some image sets in there. If you just drag that images directory, oh, get out of the way, you knob. Drag this just into the assets.xc assets thing, then that'll pull in those images that we've missed. So everybody got that? I'm sorry about that. That's not very helpful. Okay, so this is the project that we're working with, and if we first of all let's build and run it. You need to build and run it on an iPad. You could try it on an iPhone, but I take no responsibility for what it looks like. I find iPad Pro 10.5 inch looks all right. So if I build and run it on there, we can see roughly what it's doing. Then we'll take a quick look through what forms this project before going on and tackling each of those things. So build and run. You can go away. I don't need you anymore. This is going well. Here it is. Beautifully rotated, thank you. So you should start and it should load something that says you need to log in. And this uses, what's it called? Safari Authentication Controller. It's new in iOS 11. And it's really nice for being able to log into services that like OAuth type services that require you to log in through the web. It's a nightmare to log out again, but we'll worry about that later. So, well, we won't. I will worry about it later. So when you click login, it'll ask you whether or not it wants to let you use raywendlick.com to log in. This is all because you can no longer share cookies between Safari sessions and app sessions. They invented this new thing to be able to do it. If you want to know more about it, feel free to look at the code. All we're going to do now is actually log in. And it should throw you up with the standard raywendlick.com login page. And if I put my username in there, so if I should be able to log in using that, and it should send you back to the app, and you get nothing. You get a completely blank screen. If you remember back to the video, this should be a list of all the courses, but it's not. Why is it not? If we go back to Xcode, then we look in here. It's a bit of a mess. Get this out of the way. There's a load of Mac errors. And then somewhere down here, it says it's unable to decode, expected to decode some stuff. It's basically, it's the date formatting is the problem. So we're going to fix that now. So let's stop it. I think maybe before that I'll show you a little bit round through the app because you might be mildly interested in what's going on here. There's a little bit of IOC stuff, a little bit of dependency injection going on right at the top, not particularly interesting. Layouts, I don't use storyboards or anything. I use a project called Layout, and all of the layouts are defined inside XML in there. If you want to talk to me about that later, you're very welcome to. There's some view models, there's some custom views for collection view cells. There's a load of standard kind of view controllers. And there's a load of models, so some of these models we'll be looking at later on. And then inside the services directory, you'll notice something called Betamax API. If you open that, you'll see that actually this is pretty much the thing that you just built. There's a few extra endpoints, but this is what you built. This is the thing that we use to communicate with the API. We're going to start in the file called Betamax. And inside here, this is effectively the data store that has the methods that we use throughout to request the data. The first thing I want you to do is find on line 38, there's this JSON decoder object, and it has a date format in there. We could have typed that out, but I don't think anybody would have enjoyed doing that. I certainly wouldn't have enjoyed trying to type that garbage out. The thing what this does is it produces a JSON decoder that then Moya uses throughout to decode the JSON that comes in. And we just want to customize this. So what I want to do is tell this JSON decoder to use that date format, which is quite easy to do. So I'm going to do let date formatter, and we're going to create a date formatter. And then I can specify on that date formatter that its date format should equal that date format. Okay? That's just a standard date formatter in the olden days, NS date formatter, all very simple. And then once I've got that, then I can tell the decoder that I want to use the date decoding strategy. Notice here that there are two things. One is called date decoding strategy. One is called data decoding strategy. They're one character different and very easy to get confused. So go for the date decoding strategy, and that is going to be .formatted, and then you pass in the date formatter that you want to use. There are various other things that you can do in there as well as standard date formats, but that's what we're going to do. Now, if you were using Swift 4.1, then you could also do the key decoding strategy, which turns snake case into lower camel case, but we can't do that in Swift 4, and in fact, throughout all of the model objects, then that's manually done at the moment. Now this, in most places, this JSON decoder is already being used by Moya, but let's see how we can actually do that. So we use this in several places. One of them hasn't been updated yet, so let's take a look at that. Now, we're going to do that in one of the methods on this Betamax object is called getScreencasts. And if I scroll down and find it, it's here. Look, it's getScreencast. Should be on about line 140-ish. Then we've got the same thing that you saw in the playground before. This provider request shows screencasts, and it got the success case. And I've got this here that says to do update to use a custom JSON decoder. So we should probably do that. And we're going to do that here with this response. Then it maps it. And we're going to tell it at the point that it's going to map it, we're going to tell it that you need to use this particular JSON decoder. And we also need to tell it, as we did before, a particular key path. So I'm going to put at the key path in first. And the key path that I want to use is videos. This is precisely the same as you did in the playground. And then there's a using property, or argument, I suppose. And we pop in there self-JSON decoder. So that will go and grab the JSON decoder from that lazy variable, that thing that we just configured with a particular date format we want to use, and that will mean that it then manages to decode the dates correctly. Okay, so if you build and run that again, in theory, that will work. We go back over to Ematron, should already be logged in, and now you can see that it manages to decode that JSON, and it gives you a list of the different courses. As you scroll through, you should be able to see this is all of these are all of the video courses that are available. Grand. So that's the first part of it, is customizing the JSON decoder and how you can customize it when you're using Moya, but again. That's not necessarily how you would have to do it. If I now tap onto one of these particular courses, then it will load up some information about that course. And down at the bottom here, there's this thing that says videos, and you might expect there should be a collection view of the videos that comprise that course. I think that makes sense. Right. That doesn't work yet. Now we're going to look at why that doesn't work yet, and we're going to fix it. Go back to Xcode and open up a file called collection.swift. It's inside Emetron models. Get rid of this out of the way. And if we take a quick look at that, it's a class, it's a subclass of content. Now I'm just going to show you what content looks like. Content is a subclass of object, which is the realm object. That's the thing that gets persisted, saved into the realm database. Content has a load of variables on there that's actually shared between a video and a collection. So we don't need to care about too much. But there are things like a piece of content has a name, it has a language, it has a release date, it has an editor, a platform, some difficulty, various other bits and pieces. This currently works, right? We don't need to do anything with content. Our problem is with the collection type here. In fact, we've got here this thing that says add decodable conformance. And the reason for this is it's managing to decode lots of stuff about the collection, but there are some specific things in the collection subclass that it can't do. And we're going to look at those now. So this is basically how do you do custom decoding using decodable. And as I mentioned before, the reason we have to do this is because the Swift compiler can't do it because it's a subclass of a realm object. So what do we do? If we go down here, where the to-do is, and the first thing we need to do is tell the Swift, to tell it which keys, what things do we expect to find inside the JSON that we want to turn into our properties on our class. We do that with a private enum, which is going to be called coding keys, and it's a string, and implements the coding key protocol. And in there we need videos, and we need video count. So these are the two properties. If I scroll up very briefly, these are the two properties here, videos and video count, that we've added in the collection subclass of content. There's a load of properties that already exist in content. These are the things that are specific to collection. Now, the first thing here is this video count is just an integer. That looks very simple. And a collection has many videos, which you might expect would be just an array of video objects. But that's not the way realm works, because the realm is forming a relationship between the collection and the list of videos. So that's the way this works inside realm. And that's one of the reasons that Swift can't handle this. This is just standard realm stuff. If you don't know it, it doesn't really matter. The point is that if you're using realm, this is how you build relationships. So these are the two properties that I want to be able to decode. The first thing I need to do is actually this video count property. We call it video count in lower camel case like that, but that's not what the JSON API calls it. It calls it snake case video count. If we were using Swift 4.1, we wouldn't have to do that. We'd just tell it the key decoding strategy. Here we need to tell it that it needs to look in the JSON for video_count, and we will use video count in lower camel case. Once we've done that, if you remember back to what is the method we have to implement when we are implementing the decodable protocol, it's quite simple. It's an initializer, and it's called init from decoder. So I'm going to implement that. And then this is exactly the stuff that you do whenever you're implementing your providing your own implementation of decodable. The first thing you need to do is create a container. Get a container. And this comes from the decoder. And you can ask it for a container. And there's various different types of container that you can ask for. There's a single value, so I only have the bit of JSON's only got one value in it. It can be an array, which would be an unkeyed decoding container. An array is a container of objects that are unkeyed, well, they're keyed by index, I guess, but they're unkeyed, versus keyed, which would be a JSON object, a dictionary. So we want a keyed decoding container, and it is keyed by coding keys, and then put a .self in, because we want the type, not the object itself. So once we've grabbed that container, this is the part of the JSON decoder that will try and it interprets that underlying JSON as properties for us to access. We can then populate video count. Oh, not if I do that, I can't. Video count comes out of that as try container dot decode, and then you put in the type. It'll be an int. And for key is video count. This is what the Swift compiler does for you in most, like 90% of the cases that you're using decodable. We have to do it ourselves. Now, the next thing that you might imagine, like, wow, we're on a roll now. What I can type is videos then. Must be try container decode. We put the type in. Well, I want an array of video. Dot self for key. Oh, God, not that. Self for key dot videos. That'll work, right? Well, no, it won't. This would work if you weren't using Realm. Or if you had an array of videos as your property, this would work. But this doesn't work because if you look back up to your property definition, it's not an array of videos. It's this funny list type that is angle bracketed with the word that I can't remember, on video. Somebody clever remembers it. Greg remembers it. Thank you. It's generic on video, so we've specified that it is that it contains videos. So this doesn't work because we don't want an array. So what we'll do instead is do if let videos equals try with a question mark. So then videos is an array of these video objects. Then what I can do with that is take my self.videos property, and I can append. Oh, come on, give me the append. Append. I don't want to type it. Objects in. There we go. Objects in sequence. So what that will do is this append method is something that exists on the list class that comes out of Realm. So I've grabbed my videos as an array, and I'm just going to stick them inside this list. Simple. And then I've done the things that are specific to my collection. I now need to finish off by filling in all of the properties that I inherit from content. And I can do that with try super.init from decoder and pass in the decoder. And that will finish off those properties that I've inherited. Does that make sense? So I can't populate it with an array directly, as you would do if you had a property that was an array. So instead, I grab that array and then I stick it into my list. Nice and simple. Now, because Swift is Swift, I've implemented one initializer, therefore we need to implement all of the bloody initializers. So if you start going through this and asking Xcode to fix things, then it will provide you with 3 more initializers. It has to init with Realm schema. It has to do the empty initializer, and then there's another one, init value and schema, both from Realm. Now they're currently fatal errors. We don't really want fatal errors. We just want to defer to our superclass. So take out those fatal errors and replace them with super. So this is super init Realm is Realm. And schema is schema. In a proper language, you would just say super here. Or you wouldn't do it at all. But Swift's a bag of balls. And then this one here, if I do super init, like that. And then finally down here, I'm just going to do exactly the same again. Super.init. Value is value. And schema is schema. There we go. No, not that. Schema. Now, if you've ever tried to subclass Realm inside Swift before, then you come up with this problem that it doesn't know what RLM schema is or RLM object schema. Then you have to import, in addition to Realm Swift, you have to import Realm, and then it gets those type definitions in for you. So that there is like, we're just fixing some of the issues. Okay, so now if we build and run, hopefully we'll see those videos arriving, because a collection now, when you decode it, it knows how to populate its videos relationship. So if I go back, build and run, and wait for it, then it'll install it. And we can choose a collection, and when you choose a collection, we now end up with the videos down at the bottom, because it now knows how to decode that extra information that we're getting from JSON into the correct relationship that we have inside Realm. Or we're using Realm here, you could use anything. It doesn't really make any difference at all. But that's good. And in fact, I think if I click on that, then it will take me off to a page that's about that specific video. Okay. The next thing I want to quickly finish off, if you remember I was talking about the reactive paradigm that you get from Realm. And we're going to see that if I go to the screencasts page, then it's completely blank. And that we're going to see how to fix that using the reactive paradigm. So go back to Xcode and open up screencasts view controller. Swift. Get this out of the way. We're going to take a look at roughly how this all works, because this is the thing where we're using the reactive paradigm to kind of abstract away some of the asynchronous things. So with a network requests, then they're asynchronous, right? We send off a request at some point later in time. We will get called back with either an error or a response. And there's no reason why you can't use that throughout your app, but you end up with handling these asynchronous things all over the place. By using the reactivity that is built into Realm, or if you built your own reactivity type thing, or you could go and use, if you hated yourself, you could use RX Swift or Reactive Cocoa or any of those kind of things that you want to do, then you get some really nice things out of it. And one of them is the fact that you probably no longer need to consider the asynchronicity quite so much. So how does this work? If we look down at the bottom, we should see that the screencast page effectively has, here it's got a UI collection view data source. It's a collection view. It just populates things with the standard bits and pieces. The thing here, though, is it's grabbing this return videos.count. And then down here, we grab some stuff out of that videos list. Here, videos, and it pulls the data model out of that videos array and gives it to the cell to draw itself. So what is videos? If I scroll up to the top, you can see I've got this private lazy variable videos, and videos is something that you ask the store, which is the Betamax thing we were looking at before, this get screencasts method. So it asks it for it once, it's a lazy variable, so it asks for it once and then it uses it. So let's see what that screencast method does. If I jump to the definition, first thing to notice is it returns this results video. Now results is a Realm thing, and it's a reactive collection. And it contains a load of videos. Now the first thing that we do in here is what we fixed up before, is we make a request to the API to collect these screencasts. And what we do with those screencasts when we successfully collect them is we map them into video objects and then we write them into the Realm, into the local database. So that's what that does. That doesn't return anything. That just makes a request. Down at the bottom here, we've got this thing that gets returned. This asks Realm for a list of all of the videos that are of type screencast. It sorts them, and then it returns that. That returns this results object, and that's reactive, which means that if that filter changes, the results object changes. So whenever, at the point that this API call is successful, we save those into the Realm. Whatever we've done with this results object will now have that access to that data. So we've removed that asynchronicity out of it, and instead we've got this object that will always be kept up to date with whatever the results are. If I go back into here, then this thing here is a results set that changes. What we need to know is, well, if it has changed, I want to redraw my collection view. So if you find view did load in here, which should be on line 55. There's a to-do thing here, which says add screencasts observer. What we're doing here is I make a change. We've already got a property called change token. This is effectively just a, what's the word? Opaque kind of object that if you keep hold of it, you will get notifications of changes. If you let go of it, those changes will stop happening. So we just keep hold of this. And we do this thing on videos, which is the property I showed you, that's of the type results video. And we observe. And then with that, we just provide an observation block. We want weak self and change go in. And then when that change happens, so I know that the results have changed in some way, we just grab the collection view and we reload the data. So a change happens, our results object has changed, we've downloaded the data, so all we're going to do is reload the collection view. Now, if you stop that, I have a feeling that this won't work first time, but if we run it, we might have to run it twice. And go back, then it will reload. And we go to the screencasts tab, and right, it does that the first time. I don't know why, but if I stop it and run it again, it'll work. It's because it's not really designed to do that, and I'm lazy at debugging. Now if I go to screencast, then it works. So what we've got there is we've downloaded all of that data, it's gone into Realm, then on our screencast view controller, we've just said, when this thing changes, just redraw the collection view for me, and that's what it's done there. So we didn't have inside our view controller, we had no handling of asynchronous network methods or anything like that. That all happens somewhere else, and we just have this object which changes and keeps up to date, and that is so much, I think, so much nicer to deal with. And with that, that's that second demo done. So we'll go back to some slides. We're going to move on to the autosync in local cache. We've got 31 minutes. Put your hand up if you'd like a break. Excellent, good. That means I can talk more. Right, so autosyncing local cache, what am I talking about here? A viewing. We spoke about before about the fact that we want to register people's progress as they're working through something. We need to make sure that we are aware of what their progress is. The problem with this is that you could watch a video on the website and then you could go and watch the same video or a different video in the app. And I want to make sure that those things are always kept in sync. Right? I don't want to watch something in the app and then go to the website and then it not know, and I go back to the app and it only knows the stuff from the app. So we want to be able to do it so that as you watch something in one place, it always gets sent back to the API to make sure that that is the source of truth. This is roughly what a viewing object looks like. Remember that I called progress objects viewing objects because it makes the language slightly easier to understand. It has, we saw this when we went through and did this in the playground to start with. We just have a few different properties in there. The one that is new on here that's kind of important is that one at the bottom called dirty, which is joyful because now we have the phrase dirty viewings, and I apologize for the fact I'm going to say dirty viewings quite a lot throughout the next 20 minutes. But that there, you use this concept of labeling something as dirty as I've changed it in the app, but the API doesn't know about it yet. And then when the API knows about it, then it's no longer dirty, it's clean. I could have called it clean, but then you don't get the mildly entertaining joy of saying dirty viewing quite a lot. So one of the problems that we have with this, whenever you're doing any cache synchronization, or in fact any synchronization, is how do you resolve conflicts? I've got a load of stuff that is local on my device. I've got a load of stuff from the API. I want to join those two things together, but there may well be conflicts. So you need to come up with a way of doing conflict resolution. Now with viewings, with progress, this is quite easy. Right? This compared to a lot of things, this is quite easy. So the way that we do that is we look, so we're going to download a load of all of those viewings from the API. This is all of the progress that this user has ever watched in their life. We're going to download all of those. And then what we're going to do is go through each one in turn, and we're going to say, do we have a local equivalent of this? On our local device, do we have an equivalent one for the same user watching the same video? If we don't, then all we need to do is save that remote one as the local one. We don't need to do anything else with it. It's done. Like we've just grabbed the one from the remote and we've stuck it inside the local cache. Brilliant. That's no, by the way, not on. Depends which way you look at it. The next one. So yes, there is a local one. Is it dirty? Is it a dirty viewing? And is it more recent? So I'm saying that it's dirty means that they've watched it locally on this device. And is it more recent? Was it updated more recently than whatever they watched on the web or elsewhere in a different device? If it is not dirty and it's not more recent, then we want to update the local one from the remote one. That means the one that we've just downloaded from the remote is newer. It is it's more significant. It's the one we want to keep out of the two. So we'll just update the local one to match this remote one. And the final part is, so yes, we do have a local one. It is more recent. It has been more recently updated than the remote one, and we've marked it as dirty. Then we need to push the local one up to the remote API. So that is the conflict resolution for this, and that's significantly easier than conflict resolution on lots of other things, but that's all we need to do for this particular instance, which is wonderful. The next part of that then is, how do we sync back to the remote? Our sync engine is built up of 3 different areas, and this is one of them, is syncing back to the remote. Remember that results object we got from Realm before, this reactive results object that will tell us when something changes inside it? Excuse me. My apologies. We have this reactive results object that will tell us when something changes. I'm going to filter that so that I just have the dirty viewings in that. So then I have this results object that only has dirty things in it. Whenever something is marked as dirty, it will update in this object, and I can have a notification for it. Whenever something is marked as no longer being dirty, it disappears from this results object. Whenever that, I'm going to observe that dirty viewings thing, and whenever I see something, then I'm going to take that viewing and push it back up to the API. And when I've finished that, I mark it as not dirty anymore. Simple. So, demo 3 then. We're going to do a few different things. First of all, we're going to do the thing that you may have thought that we were going to do in this talk when you read the abstract that I wrote quite a long time ago. We're going to do something to do with a video player. And that is, how do I get from the video player in iOS notifications that I've watched a bit more of the video? I want regular notifications saying, yes, I've watched this far now, I've watched this far. So how do we do that? Next, we're going to add the ability to seek to a particular point when you press play. So if I've got this progress for a particular user has got this far through a video and they press play, that's where they want to start again. They don't want to start back at the beginning. So how do we do that? So those 2 bits are to do with video playback in iOS. That's probably the thing that you thought you were going to get. Well, for that, I apologize. And the next one is, how do we do the merging of the remote data with the local data? That's the first part of the sync engine. And finally, how do we auto-sync the local stuff back up to the remote API? That's all the stuff we're going to cover. So for this, unfortunately, you can't carry on with Demo 2's project. We have to go into Demo 3. There's not a huge amount that's changed. I've just put some stuff in there so that we don't have to type so much during this demo. So close that one. And the other helpful thing is that, once again, we need to copy those icons in. So if you've got that icons thing again, you'll need to do that same thing again. So we'll go this time to Demo 3. We'll go go to Demo 3. We'll go to Starter. We'll go to Emetron. Xcode project. I'm going to open it with Xcode 9.2. I'm going to open it even though it came from the dangerous internet. Move that out of the way. Back into the assets, XC assets. Just drag the icons directory in again, and hopefully that will fix any issues. Okay. I'm going to switch it back to the iPad Pro 10.5 inches. So this is exactly the same project with a few extra bits of lines of code in it. It's nothing particularly major at all. So the first thing I want to do is, as I mentioned, to receive notifications from the video playback as somebody watches something. So if you open up, there's a file called video player. It's inside Emetron services. This is a very simple object that has a method on it somewhere called play video. And or in fact, sort of here, play stream is the important part. So we provide, from the API, we get an HLS stream endpoint, so a fairly like standard way of playing back videos. And we pass that to this method, and we pass the viewing, which is the progress for the current user, and then it's going to do some stuff with that to be able to start playback. And we use, to do playback, we use a, what's it called? It's an AV Foundation video playback view controller thing, which is really handy because it gives you all of that functionality you expect. If you want to customize exactly what you see when you're doing video playback, you can do that, but you get quite a long way with the default iOS implementation for being able to do picture-in-picture and such like, or popover, I suppose it's called. So first of all, inside this method, this play stream, if you scroll down, then there should be on about line 81, or in fact on line 81, something called here to do add a time observer. So there are two different types of observers. So I should mention, first of all, this is using an AV player. So we have this AV player, which is kind of the model object for video playback. It doesn't have any UI. We passed this AV player to something that can do the playback. But this is like, if you imagine the remote control buttons, that's what that does. It tells you to play, pause, you can go at different speeds, you can line up different assets and things to play them in order and the such like. This is kind of the model behind the playback. So we have an AV player, and I want to do, it has two different ways that you can observe time changes in it. One of them is boundary times, and you would use that for like interstitial ads or something. When you hit 10 minutes and 5 seconds in this video, you need to pause it and play an ad instead. You can get that notification. Or the thing that we're going to do is I want a periodic time observer. So every 5 seconds, then tell me what our progress is, because I'm going to save that. And that's what we're doing here. Now, what we would do here is we could add this interval, this CM time, which basically I've typed this out already because it's a pain in the arse to type out, because you end up with things like it's a CM time, it uses CM time scale, but it uses different capitalization to what you might expect. But that there, the point of that is a way of measuring time that works well for media frameworks. And the reason that you think, well, why can't I just use a float? Because audio samples, video samples, it's incredibly important that they occur at exactly the right time, and a float wouldn't allow you to do that, neither would a double. This is effectively just some kind of quotient, a quotient value type, I suppose. So what can we do? First thing we need to do is do a time observation token in exactly the same way that we did with the realm observation. You get an opaque time, actually you get an opaque observation token thing that if you keep hold of it, then you will continue to get updates, and if you let go of it, then you will stop. So I'm going to create one of those, and it's going to be player, which is the AV player object, and you can add. Oh, don't make me type this out. Where have you gone? Oh, we're just indexing. We'll be 20 minutes doing that. I'm just going to quit it and type it in because I don't want to have to type out add periodic time observer for interval q. Right, come on, this time you're going to work, aren't you? Player dot, yes! Add periodic, here we go. So add periodic time observer. So for interval is that interval that I created up there, which says every 5 seconds, then you need to call me back. The queue, I want this on the main queue, because why not? Dispatch queue.main. And then this here I can get rid of and do it as a trailing closure. I want weak self in, and the time is the object that I get back. And then what do I want to do with that? Well, I have a method for this, self.store.update progress for viewing. Well, the viewing I've already been provided, and the time is going to be, I have to map it to an integer, time.seconds. So this is just a method on my data store. I pass it in the viewing, and it will update that viewing with this time that I've handed it. So this will get called, when you're watching the video, every 5 seconds this method will get called, and it'll update that viewing object.
I think you're missing an optional unwrap.
Oh, yes. Should be one on here. Not there. There. I'm glad it told me that. Brilliant. This bodes well for the rest of the demo. Now, there's one other thing that we need to do with this, which is kind of a bit of I guess admin, not particularly helpful. But if you scroll up a little bit from there, there's this thing here saying to do time, remove time observer. If you're already playing a video, I don't want to keep adding more and more observers to it. So just to clear that up, just to tidy this up, then we can do player.remove time observer, and then pass in the time observation token. And then I'm also going to set it to none. And that just clears that out so that we're not going to try and continually add observation methods. Finally, with this thing, so now what we're going to do is we're going to get updates when as somebody watches something every 5 seconds. The final thing we need to do is down about line 89, 90 to do jump to the correct start point. So I've been given a viewing and it tells me how far through a video somebody's already watched. That's where I want to start playback. I've created this start point, which is another CM time because I didn't want to type all of that out. But once I've done that, all I can do, I can type player.seek2 and pass in that CM time, which is, is start point. And that'll ensure when you start playback, it will start at the correct time. So if I build and run, we're now going to give the network a run for its money as we try and all of us play back video at the same time. Bound to work, right? Not a chance at all it'll go wrong. So if I go back into Ematron, and hopefully it'll load up. There we go. I'm going to choose something from publishing to the App Store. I'm going to choose Getting Started. All right, yeah, so if you're a subscriber, then you can choose any video you want, and it'll work because you pay us money, and we like that. If you're not, you have to click one that says free, because otherwise it just won't work. To be honest, I don't know what it'll do. It just won't work, maybe. And if you hit the play button, then hopefully it will start up, and you'll see the video starting, which is good. I'm just going to scroll to a random point in the video, and I'm going to close the video. And you'll see the first thing you'll see is that down here, I zoom in a little touch on there, there's this progress bar at the bottom of this little picture. That's updated to where I got to. The reason that worked is because this cell, this little view, adds an observation as a progress observer onto the viewing that it gets given. I updated that viewing every 5 seconds. It got updated. And then this automatically, using the fact that it was observing it, updates itself reactively. I didn't have to go and code any of that. That was already done for me. And then the other thing that I do, if I hit play again, it should start back in exactly the same place that it started before, which is kind of what I wanted to do. So that part there is everything that we're going to do from a video perspective. All right, make some sense? Magic. 2 more things to do then. First of all, I want to import all the viewings from the API. So I've already got progress. I've already watched stuff on this account. I want to make sure that the app respects that and tells me which things I've watched and how much of them I've watched. And effectively, what this means is we're going to implement this conflict resolution thingamajig. So how do we do that? Let's go back into here and open the file called syncengine, engine.swift. Which again is in the services directory. And scroll down. There's a. Do I want sync engine? Yes, I do. There's this method called sync from API. It's got some warnings in it, and none of this is particularly clever. I've just implemented it already because otherwise we'd be here for hours typing all this guff out. All we're doing is we request the viewings for the user. That's the method that we implemented in the playground. We then jump onto a queue. We grab all of the local viewings from the realm. We then loop through each of the viewings we've pulled from the API. And at that point, we're going to implement this method, this conflict resolution, where this to-do is. So inside, for viewings in viewings, grab that to-do, and let's start implementing this. First part is, does a local viewing exist? Well, let's see. So if let local viewing equal local viewings dot filter, and inside here, video ID is equal, this is just a, I've forgotten the word, predicate, an NS predicate for that's how you filter things inside Realm. So I'm just going to find a video ID that is equal to viewing.videoid. And I only want the first one. So if I manage to find a local viewing, then what do I... Oh, what's wrong with you? Ah, fist. Oh dear, that's inappropriate. Sorry. And so if a local viewing exists, we do this, and if it doesn't, we do this. So we've got an if. Let us... Yes, let's put an else in, and that's the two cases. Let's start with the if one does exist. Then what I want to do is move on to this box here. So is it dirty and more recent? How do we determine that? So if local viewing is dirty, and local viewing, local viewing.updated at is bigger than, and then the remote one is just called viewing. Go away. Get out of my life. Little v updated at. So if the local viewing is dirty and it's more recent, then what do we do with it? We have to sync it to the local API. So we sync the local one to the remote one. But actually, we don't need to do anything, and we'll see why later on. That's a no-op, because it's marked as dirty. The other half of the sync engine that we'll implement in a moment will do that for us. We don't have to do anything. Otherwise, what do we do? Otherwise, we have to update the local from the remote. So let's do that. So we do local viewing.update from, and the remote is viewing. So that's just a utility method I put on there that copies the properties from the local to the remote. From the remote to the local. So now we've handled this part of it. We just need to handle this orange box down here, save as a local viewing, which actually is very easy inside Realm. We just do realm.add, and the object is called viewing. So that saved the remote viewing to the local one. Yeah? So we've implemented the conflict resolution, quite nice and easy. Now, if I build and run this now, if you've watched stuff on the website, then hopefully it will now start to show your progress through those. We shall see, though. So I can't remember what I've watched, which isn't particularly helpful here. If I go into there, I've not watched any of them. Ah, here's one. This one here before, in-app purchase. I have not watched that here, but I've watched it on the website, and now I've got a progress for that. It's pulled it down from the API, it's updated my local cache with those, and therefore it's filled in that bar. And I think if I go to screencasts, then it might be easier to see that I've never watched a screencast. Where are the screencasts with me? And I'm probably bound to have watched those. No, I've not watched them either. I haven't watched any screencasts. Brilliant. Great advertising, Sam. Well done. So what we've done there is we've synced the remote stuff to local. The final part of this is the bit that I missed out in there. It was a no-op. Is I want to take the local stuff and push it up to the remote. How do we do that? We're still in the sync engine file, and if you scroll down, there are two methods we're going to implement here. One is configure listeners, and one is sync to API. So take the configure listeners one. This gets set up when you first start the sync engine. It sets up some listeners to find dirty viewings, and when they change, then we'll sync them to the API. So inside configure listeners, get rid of that to do, and we'll first of all grab, we'll find all the dirty viewings. And we do that with realm objects of type viewing.self. That's just a way that you query realm to get hold of stuff. We're going to filter it for all of the ones where dirty is true. That's again using a predicate filter. So that result will be a results object that will always contain dirty viewings. When they're no longer dirty, they'll disappear. When something is made dirty, it will appear in there. We're back onto creating a notification. So I've got a dirty notification token already set up. This is exactly as we did before. We have a result. We observe it. And with this, I don't care about the thing that's going in. Oh, I do care about the word in, though. And all I want to do in here is loop through the results in the viewing. So for viewing in result, result. All I want to do is call this sync to API method. No, that's not what I said, is it? Sync to API, and I pass in the viewing. And I'm just going to keep hold of that as well. So dirty viewings equals result. The reason we keep hold of it is so that, we keep hold of it so that we continue to get notifications. Very nearly done. The final thing I need to do with this is to implement this sync to API method. Most of it's already in here. We're calling this the sync viewing to API method on the store object. There's one thing that we need to do, and that is to make sure that once it's been synced, it no longer is marked as dirty, because otherwise that'll just be an infinite loop. So what do? This is a fairly standard bit of realm. Self.realm.write, not write-ev, write. Viewing.dirty equals false. Oh, that should be a try, sorry. In fact, I'm going to change this. I'm just going to put a try exclamation mark. No, it should work. We haven't got time to go into handling the error. Okay, so all that's doing is updating the dirty value to false so that it's now no longer appearing in that results object. And finally, if we scroll up to stop sync, which is on about line 47. So I want to be able to tell the sync engine to stop syncing. I've told it to start when it sets up the listeners. I want to tell it to stop. So how do I tell it to stop? Well, remember, this is very similar to what we did before. We do the dirty notification token. We can call invalidate on that, which will stop it from receiving updates. And then dirty notification token, set that to none as well, and that will clear that out. Okay, that's everything that we need to do. So what we can do now is hopefully see this in action. Hopefully. So I'm going to start it. I'm going to go into a screencast. I'm going to choose this Getting Started with Flutter that Joe produced this week, recently. I'm going to start playback. Oh no, well that won't work because I don't own it. Let me find a free one. Free one. There are no free ones. I'm going to go back to courses. I'm going to choose, let's choose this server-side Swift with Vapor. Spelt wrong. And in here, what's going on? Not working. Why are you not working? Programming in Swift? Where have all my videos gone? Let me just stop it and restart it. I apologize. Publishing to the App Store. Getting started. Let's play that. I'm just going to scroll along over to the end here. So I've got like 2 minutes 14, 2 minutes 13 seconds left. I'm going to stop it. And that's updated there. The important part is, has it updated the website? Let's try and find out. I need to log in as that user again, hopefully. So if I go to videos, I'm going to log in. My user is Sam Emetron. So that logs in, and I go to courses. I remind myself what it was called. It was publishing to the App Store. Publishing to the App Store. And if I look here, in theory, it then says it's 11:28, and that should match exactly where this it's roughly the same. I'm sure it is the same. So that there has managed to update it from and push it back to the API, and then that means that the website now knows where we are. So all of that entire sync engine is built out. And to be honest, we've built most of that in like 25 minutes, half an hour. It's quite easy because of the reactivity that we get from Realm. So in my remaining 4 minutes and 2 seconds, I shall talk about a conclusion. So what did you learn today? Well, I hope you learned something. In the first demo, we saw how you can use Moya to model a RESTful API, which I think is quite a nice way. And even if you don't want to use Moya, then You don't have to, but I like the technique of using an enum to represent an API, and then you abstract all of the networky stuff way away from where you're actually using the API. So you can stick all of that in there. Moya's a nice way to do it. You can do something very similar yourself should you want to. In demo 2, we saw how I can use Moya and Realm and Codable together by looking at what you can do with how you can implement your own, provide your own implementation of the decodable protocol. Some of the things that you might want to do with a JSON encoder, like providing a custom date formatter. And also, and how you can use the reactivity that you get from Realm to remove some of the asynchronicity. So again, you don't necessarily have to use Realm, but maybe consider using some kind of reactive type things to be able to remove some of the pain that you get and the many kind of pyramids of doom type thing that you get from handling asynchronous stuff. And then finally, in demo 3, we saw how you can build a local cache using Realm, using its reactivity, how you can use that, how you can sync it back to the API, how you can pull it from the API as well. So one of the most difficult things that you can do, I think, I'm not a computer scientist, but I believe it's a hard thing to do. We managed to get a fairly reasonable, simple working system up in about half an hour's time. Wicked. Where to go from here? If you want to look at Realm, then go to realm.io. There's loads of stuff on there. They've got loads of interesting... they've got loads of like videos and things about any iOS stuff. If you want to do Moya, then there's a good GitHub site with that. If you're interested in Codable, then I think you probably should have gone to... did Ray do a talk next door on that about like earlier today? You should have been there. Otherwise, I did a talk about Codable in Swift 4 at iOS Conf in Singapore. You can watch the video of that. There's also a screencast that I think Brian did about using What's New in Foundation about parsing JSON in Swift 4. You feel free to abuse me on Twitter. I want my real name. Thank you ever so much for watching. And I believe that with 2 minutes to go, it's lunchtime. We shouldn't have any questions. Thank you.